So welcome everyone. I'm going to show you a few problems that do t-interval problems. Today in class we talked a little bit about what the t-interval was and how it's different from the normal interval or the normal distribution and what we have to look for to be able to really tell the difference. And the key thing is that we don't know the standard deviation. And so the first thing we want to do is we want to be able to find the critical value T of C for a given confidence level and sample size. Okay, and so we're going to do that right now. And so our given confidence level is essentially a 90% confidence interval, and we have a small sample size 10. And what we'd like to do is we'd like to find the critical value T of C. Just like before in the z's, if this was a z, then we would have drawn a picture like this. This is 90%. This area here is 5%. And therefore, we would go look up the 5%, and that would give us the critical value z critical. That's what we did before. Well, what's the same? Well, the reality is it's basically the same. The t-distribution is also bell-shaped. We're essentially going to have 90% in the middle and 5% on each end. And what we'd like to do is we'd like to find these critical values right here that represent what we need to be able to make a confidence interval. And essentially how many standard deviations away are we. So how are we going to do that? Well, one way is to use the table. And so what you see here is the confidence interval table. And what I want to tell you is that based on this confidence interval table, what we see at the top in the confidence interval table is what's called the level of confidence. And so if our level of confidence is 90%, then I just need to look at the 90% column. If my level of confidence was different than that, 95 or 99, then I would look at those columns. The second thing we need to know is how many degrees of freedom do we have? Well, our degrees of freedom in this problem, our degrees of freedom are equal to the sample size minus 1, or 9. And so if we slide this up a little bit, we can look at the table, and we're going to look at the 9 row right here, and the 90% column right here, and that gives us this number right here for the critical value. So we would say that the critical value is plus or minus 1.833. Now we can also use our graphics calculators to do this. So on the calculator, you would go to the distribution menu, and you would use something called the inverse T, where you would list the probability to the left, so probability left, comma, the degrees of freedom. So for our problem, the degrees of freedom is 9, and the probability to the left, since it's a 90% confidence interval, is 0.05, and you put a comma between those. And if you do the inverse T, it gives you negative 1.833. So it gives you exactly the same value as the table. And that's how you find a critical value with a T distribution, using the table or using the calculator. So the second type of problem we're going to do is finding the margin of error. So how do we find the margin of error? Well, it's going to be very similar to what we did in the last section. In the last section, the margin of error was equal to the critical value of z times the standard deviation divided by the square root of n. Well, in this case, our margin of error for a t-distribution is going to be the critical value of the t times the standard deviation over the square root of n. And this standard deviation, if you'll remember, comes from whatever the sample is. So I can do this actually fairly quickly. First of all, I have my confidence level is 0.095. If I have a confidence level of 0.095, or excuse me, not 0.095, 0.95, if I have a confidence level of 0.95, that means I have 0.025 in each tail of the interval, and therefore I can do inverse t, where I list the probability to the left and then the degrees of freedom. Well, my degrees of freedom are going to equal 16 minus 1, so that's 15. And so if I do that, I will get a critical t value equal to negative 2.13. So it could be plus or minus that. And then all I have to do is use the standard deviation in the sample size to find the margin of error. So my margin of error is equal to negative 2.13 plus or minus 2.13 times s, which is 5 over the square root of 16. And that'll give me that my margin of error is 0.266 approximately. And therefore, and that's all you have to do to find the margin of error. So to review, because we're using a t-distribution, this is our margin of error. And since it's a t-distribution, we can use the inverse t on the calculator. The only things we need to know are the degrees of freedom and the probability in the left tail, 0.025. That'll give us our critical t. Now, if you wanted to use the table, you would have gone to the table and you would have looked up 0.95 on the table and went down to 15 degrees of freedom, and it would have given you the same number. Once you do that, it's critical t value times standard deviation over square root of the sample size, and that gives you your margin of error. Okay, next slide. So the last thing we want to do is construct a confidence interval. So we have a confidence level of 90%, x bar is 12.5, our sample standard deviation is 2, and the sample size is 6. So right away I'm going to find my degrees of freedom, which is 6 minus 1, or 5. And I'm going to paste the table, because I'll use the table this time and then check it with the calculator. So I have the table, so I'm going to proceed forward. So to find a confidence interval, step 1 is always we need to find the critical value. Step 2, we need to find the margin of error. And step 3, then we can make the confidence interval. And so the critical value is pretty easy. We have a 90% confidence interval. And that 90% confidence interval takes us to this column right up here. And we have 5 degrees of freedom, which takes us to this row. And so if we run those down together, we're right here. And so we know our critical values are plus or minus 2.015. The margin of error is always equal to the critical values times in this case, the sample standard deviation over the square root of n. Our sample size is small, so this is the proper formula. So we take the critical values, plus or minus 2.015, and we multiply times the sample standard deviation, 2, divided by the square root of 6. And that is going to give us equal to 1.645. Funny, that's a nice answer that we've seen other places. And then the confidence interval, and that's plus or minus, by the way, and then the confidence interval is just going to equal the sample mean plus or minus the margins of error, and that creates an interval. And so the -1 is listed first. So our sample mean is 12.5, and I'm going to subtract 1.645, and I get 10.855. And then I take 12.5 plus the margin of error, which is 1.645. And that gives us 14.145, and that is our confidence interval, our 90% confidence interval. So your problems tomorrow are just these basics. And keep in mind that this table is used much differently than the other tables. Last thing I want to show you is how can I get the critical value? How can I get the critical value if I'm using the calculator? Then I would use inverse t under distributions. Since it's a 90% interval, that would give me 5% in the tail, and my degrees of freedom is 5. And I'm just going to calculate that now. And what I ended up with is essentially exactly the same answer I got here. So you can use the table to find it, or you can use the calculator. Now where the calculator really helps is if you look at the table at these confidence levels, you only have very specific confidence levels. So if we wanted a confidence level that was not listed here, like 92, 96, 85 or something like that, then the inverse t really helps us in those cases to get the correct critical value. Okay, that's all I have for you. You can do the homework tomorrow.